Hi, welcome everyone. My name is Himanshu Verma, and today in this topic, we will cover layering AWS security services to automate incident response. I'm a worldwide security specialist with AWS, and today we will walk through some of our threat detection and monitoring services and how customers can leverage those services. The agenda for this presentation will be to give you an overview of native AWS security services in the threat detection and monitoring portfolio, how customers can enable these services at scale, adding automated response, which is a key criteria of ensuring that you can take actions on some of the threat detection findings, and best practices along the way. So with that, let's dive right into this. AWS has plenty of native AWS security services. With the breadth and depth of our native AWS security services, it's important to see and analyze how customers can structure these services for various different use cases. One of the ways to do that is to align them with a known cybersecurity framework. The NIST cybersecurity framework is one such example. So here we're illustrating how customers can leverage our native security services as well as some of the management and governance tools to align them to a cybersecurity framework. First and foremost, customers need services that can identify the key resources in their environment. AWS provides some of the key services such as AWS Security Hub, System Manager, and Config that help them identify where all are their key assets and resources in the cloud. Once customers have identified those resources, next in line comes protection, which is the ability to protect data, workloads, resources at rest, in motion, or at use. This is where our native security services that provide data encryption for data at rest, in motion, or use can be helpful. Services that provide key management so that encryption services can leverage keys that can be rotated and well maintained and managed, as well as infrastructure protection services that can protect data to and from the cloud can be leveraged. Using these, customers can layer data protection and protect their infrastructure as well as resources in AWS. Then customers need the ability to detect proactively any threats and or any misalignments from known good behavior or known good standards. AWS provides several detection services that can be leveraged here. We will dive into these later in this session today. These detection services provide customers with insights that can then be leveraged to either automate a response and take actions, or customers would probably want to go in and investigate based on their security posture and based on their maturity of their security cycles. Security analysts also like to go in and investigate and find the root cause so that they can take more precise actions. This is where using the combination of native automation services and tools, as well as native investigation services, customers can take precise actions to respond to these threats or findings that have been detected. And then finally, when it comes to taking response actions, recovery from an introvert incident and or from an unknown behavior is one of the key aspects where customers can leverage some of the native services that provide automation, such as CloudFormation or OpsWorks, or recovery tools such as Cloud Endure or AWS Backup to orchestrate these responses. So you can see here that with the breadth and the depth of the services, customers can actually orchestrate and formulate these services into a cybersecurity framework to ensure they are leveraging the layered security architecture. Now let's zone in on threat detection, monitoring, and response. AWS's threat detection, monitoring, and response services are natively integrated with AWS resources. If you look at an AWS account, which is the logical construct of where customers' resources reside, whether it's their networking resources or their database and compute resources, we have services that can natively integrate with AWS accounts, and at the account level can automatically start providing value to customers. Some of the primary services here are Amazon GuardDuty, which is a foundational detection service to identify known and malicious threats. Amazon Macie, that can identify sensitive data at scale and ensure that customers are staying compliant with regulatory needs or handling their customers' personal data. And finally, Amazon Inspector, that can identify any known vulnerabilities in instances. All these services are enabled at the AWS account level without customers having to do any other additional telemetry collection or log collection. Once enabled, these services are continuous and report what are known as findings. Those findings can then be aggregated in a centralized monitoring service called AWS Security Hub, which also acts as an ongoing continuous compliance assessment service. And AWS Security Hub provides that ongoing visibility and the centralized monitoring capability to customers. From there, customers can further investigate some of the findings that have been reported to identify the root cause, leveraging Amazon Detective. And once they have identified the root cause of those incidents, they can then orchestrate automated response and take action on those findings. So these are the 5 core services that customers can leverage in our threat detection and monitoring portfolio, and how they can orchestrate automated response as well. Let's dive into these a little further now. When we talk about layered threat detection and response, the first and foremost thing that customers should look into is how can they scale this, and how can this be leveraged so that they can integrate this in their current DevOps processes. So the first layer that customers should really take into consideration is how to scale this across their AWS accounts. As I mentioned earlier, most of these services can be enabled at the account level. And one of the things that we have done is to introduce native multi-account management for all these services, which means when security teams have larger scale or they need to manage these security services across multiple accounts, they have one-stop shop to go and enable these services. In each one of these services, there's an option to delegate a centralized management account, which can be the centralized security operations account or the centralized security tooling account, based on which customers can then easily onboard multiple member accounts. The native AWS organizations integration for these services allows customers to delegate that centralized management account, which could be the designated security account, from where the onboarding of multiple accounts as well as managing of these services in those multiple accounts becomes very easy and simple. Using a few clicks, this can scale to all of their AWS accounts. So this is one way and a best practice to keep in mind. When we talk about layer detection, the first and foremost is the foundational detection service in that layer, and that is Amazon GuardDuty. Amazon GuardDuty is a native AWS security service that provides customers with the ability to protect their AWS accounts, workloads, as well as data stored in Amazon S3 against known threats as well as unknown threats. The way this is done is very simple. GuardDuty can be enabled using one-click activation, and once enabled, it is automatically ingesting the required telemetry for the protected resources that it covers, and that telemetry is then fed into our threat intelligence as well as our machine learning algorithms that are then continuously identifying any known or abnormal behavior that is identified. It also provides global coverage across multiple regions, so it can be enabled across all regions. And more importantly, using that centralized account management with AWS organizations, the team can aggregate all the known findings or abnormal findings as well in one place. Let's dive a little deeper into how GuardDuty works. First and foremost, natively within AWS Cloud, once the service is enabled, it is automatically looking for events that are related to any network activity, which is usually recorded in VPC flow logs and DNS flow logs at the account level. Secondly, it's looking for any API activity, which is recorded in CloudTrail events. And it's also looking for any data access events For example, S3 data put and get APIs, which is in the CloudTrail data plane events. The one key thing to remember here is that customers do not have to enable any of these log sources separately. GuardDuty, once enabled, automatically creates a private channel with the required amount of telemetry that's needed from these log sources, and they are then fed into the service and evaluated against, number one, threat intelligence. When it comes to threat intelligence, AWS curates and maintains its own threat intelligence. In addition to that, we're also partnering with our security partners to bring in their threat intelligence automatically. We leverage partners and security vendors in the industry, such as CrowdStrike and Proofpoint, in addition to our own threat intelligence. And finally, we also provide customers the ability to add their own custom threat intelligence, which can be done either at the account level or at the AWS organization level. That threat intelligence is then able to highlight and detect any known malicious content. For example, any IP addresses or domains which have been listed in known threat attacks around the globe, or any bad actors that have been known for command and control type activity, and or the most recent and latest trends around Bitcoin mining and or crypto mining, etc. These threats are highlighted, and the additional context as to which threat intelligence provided us the input to highlight those are reflected as well. Secondly, we leverage machine learning for anomaly detection. Once GuardDuty is enabled and we start collecting the telemetry in the account, we're also looking for variances in the learning behavior of the service. So the service starts to create a learning model, and from there we are able to identify any abnormal activity. Now, what's key here is that some of these activities could be non-threats or not known threats. However, it's important for the security teams to identify abnormal activities such as data exfiltration or requests coming in from unusual ports or probes, or even from locations. These are some of the things that will be recorded and will be identified using that machine learning model. All of these known and unknown threats are then identified as findings. The findings are available in the console for 30 days, from where they can be easily streamed off and integrated with third-party tools and or native AWS services. They are also ranked by severity, which allows the security teams to actually act on them. More importantly, we provide features where security teams can easily filter and or create their own suppression rules, how to act on them. The native integrations available are with CloudWatch events, which allows individual findings to be streamed off and can also be easily integrated into external SIEM tools or SOAR tools where the security teams might be aggregating these events. They're also sent automatically to Security Hub, which is our centralized monitoring tool, which we'll talk next. And additionally, these findings also provide a pivot into Amazon Detective, which is our investigation service. Let's talk straight into that. Amazon Detective is the next layer of threat detection and monitoring services that we recommend customers to leverage. Detective is a native service that can now dive deeper and allow customers and their security teams to go in and investigate and triage the findings that are reported in GuardDuty. Additionally, it's also natively collecting telemetry from the VPC flow logs as well as CloudTrail, and is recording them over an extended period of time. One of the big challenges that Detective addresses is where security teams need to collect large amounts of data and ingest them for long periods of time. Detective has the ability to collect all this information, and using a behavioral graph database is able to optimize the volume of the data collected over a period of time as far back as 1 year. So this is where it allows security teams to then go in and have a built-in data collection source so that they can go in and investigate and find out a root cause, triaging of security or networking events, as well as prioritizing where to take actions and what type of actions to take, And more importantly, doing forensic analysis or threat hunting are some of the key use cases that Detective can address by providing easy visual cues within the service. As I mentioned, one of the ways to pivot to Detective is once it's enabled, right from the guard duty findings itself. We also provide contextual inputs and filters, such as if there's a finding that has detected a bad IP address or a bad domain or an AWS account ID or instance ID, you can easily filter using some of these parameters straight into Amazon Detective. Additional ways to investigate findings is from our centralized monitoring tool, AWS Security Hub, which is where all these findings will be aggregated. And then finally, customers can also leverage other integrations with partner tools as well. So if you're using a SIEM tool or a SOAR tool, and you need a deep linking to Amazon Detective for investigative purposes, those are some of the options that are also available to pivot into Amazon Detective. If we look at Detective again, it's a multi-account service, so it can be enabled easily across multiple accounts. From each account, we're collecting this telemetry automatically without customers need to enable any of these log sources separately. And with that, all of this is consolidated into a single behavioral graph database. Once enabled at the multi-account level, this is again for security teams, ease of use can be all aggregated in one place. This is where Detective's behavioral graph technology comes into play that allows to create that associative property between the various different nodes. Nodes such as a user who initiated an IAM role or initiated an IAM session from a specific source, such as an IP address, and got to take an action on an instance. Those are some of the correlation aspects that are automatically built in this behavioral graph. These are easily available on a time trending basis, as well as an interactive graph and interactive visual cue in the console itself of Amazon Detective. Customers can now easily pinpoint how a security incident or a standard networking event or an IAM role or permission might have manifested across various different resources or various different instances, for example, over a period of time, what type of API calls and what volume of API calls were made over that period of time. This is very helpful for mature security teams that want to go ahead and do either forensic analysis and or threat hunting and want to narrow down the exact root cause of the security issues. The next layer in that threat detection and monitoring portfolio is how can customers monitor not only some of the findings from these security services, but also some good known security practices and or evaluation against some good security standards to maintain an ongoing compliance. And this is where AWS Security Hub comes into play. AWS Security Hub is a service that provides a full cloud security posture assessment in addition to aggregating findings from native AWS security services, as well as integration with other partner tools that customers might be leveraging. We recognize that most customers are not only using the native AWS security services, but also other security tools within their environment. Security Hub's partner integrations allows customers to integrate and bring in the findings from the built-in AWS security services as well as third-party solutions. With that aggregation, it then correlates and provides customers with meaningful insights and is continuously monitoring their AWS infrastructure against known good practices. These practices are in the form of security standards. AWS Security Hub has both internal as well as external security standards, which can be enabled, which are backed by managed controls, which are continuously assessed at any given time. Also, this is a multi-account service, which makes it easier to centralize across several regions and then allow customers to go ahead and have one centralized place to look for findings from all AWS native security services as well as other integrated services. So the way Security Hub works, it can be enabled at the account level. It is also natively integrated with AWS organizations. and allows you to do multi-account management very easily. Once enabled, it starts aggregating findings from the native AWS services that are already enabled. In addition to that, it's also taking in findings from other 60 plus partner integrations that are already natively built into the service. The native AWS security services that are already available are part of our threat detection and monitoring portfolio, such as GuardDuty, Macie for even sensitive data discovery or policy changes on your Amazon S3 buckets, Amazon Inspector for vulnerability assessment, and Firewall Manager for network security services. Being a managed service, we are continuously adding support for additional native security services into Security Hub so that their findings are automatically ingested. In the backend, Security Hub is also leveraging AWS Config, which is a governance service that allows for various different controls within your AWS infrastructure, and Security Hub enables it to automatically go ahead and evaluate these controls on a continuous basis. This allows customers to aggregate these findings as well as assess their security posture in one place, view what are the deviations from known security findings that have been reported, or any gaps between the known good security posture and control gaps, as well as automate response and remediation. One of the key benefits of Security Hub that gets overlooked at times is the ease of automation and remediation. So we'll talk about that and dive into that deeper as we move on. As I mentioned, Security Hub has some built-in standards, both native AWS internal standards, such as AWS Foundational Security Best Practices, as well as CIS benchmarks, which allows customers to aggregate these controls and view what is their security scores against these controls. We also provide external standards such as PCI compliance if customers want to evaluate their ongoing cloud security against these external compliances as well. Using those 150 plus fully automated controls in the backend, we outline what each control is and what is being evaluated. With this, we aggregate a security score that is then provided for either executive overview or to provide an aggregated insight into what is the current security posture of your AWS resources. Using this, customers can then leverage the deviations of where they are not meeting those best practices and then act on those. So Security Hub acts as a centralized dashboard across multiple accounts to aggregate these findings, view the security compliance, and monitor that at all times. And more importantly, all the findings that are routed to Security Hub are normalized into Amazon security finding format. This allows security teams to then stream off the findings from Security Hub using either CloudWatch events or EventBridge and or integrations directly built into their SIEM or SOAR tools and have one single format for their security teams to deal with. That makes it very easy for the security and the incident response team to parse these findings or build ongoing continuous automation and remediation actions. So that is our next layer of defense now, our threat detection and monitoring, which is how can customers automate response and remediation. Once customers have detected deviations in best known practices or findings into the threats that are either known or unknown, or let's say even findings from sensitive data discovery, etc., the next key item is to act on those findings, which is an important aspect in the security realm. One of the ways is to take these findings from the security tools and then act on them independently. However, the best practice is to aggregate those findings in Security Hub. So in this case, GuardDuty once enabled and Security Hub once enabled at the account level, automatically all findings from GuardDuty will be routed to Security Hub, which is where customers can then act on them. There, using the native EventBridge integration, customers can write either custom CloudWatch actions so that they can take as simple actions such as either notification into their ticketing tools or SNS alerts, or they can take more advanced response and remediation actions where they can go and take an action on either the instance or the IP address or the known threat actor that has been reported in GuardDuty findings. An example of this automated detection and response can be leveraged by looking at GuardDuty findings, which have reported a malicious IP that was matched with our threat intelligence, and then building automated response rules in the AWS Network Firewall for that account or region. AWS Network Firewall, a service that allows for comprehensive policy writing as well as rule-based engines, can then have CloudWatch events that can act as a trigger to either start a step function or a Lambda that can easily block that traffic from a known malicious URL or an IP address. These are the ways that customers can easily automate and then integrate the threat detection and security services into their DevOps cycles. Once aggregating the findings into Security Hub, there are other built-in actions in the Security Hub service that customers can leverage as well. This feature is known as Security Hub Custom Actions, which in turn trigger other automated actions using either Lambdas or step functions. So customers can define a CloudWatch rule within Security Hub to highlight these custom actions in the Security Hub user interface. Using the Security Hub centralized management console from there, customers can define what type of custom actions would they want to take on either findings that have been reported and aggregated from GuardDuty, or findings that have been reported as deviations from known best practices or controls that are being evaluated by the Security Hub standards. These CloudWatch rules could be as simple as firing off a Lambda function to take an action, or aggregating the findings and streaming them off into Kinesis data streams, or simple notification alerts such as SNS alerts, or taking an action on an instance by invoking shell commands. A combination of these rules as well as sets can be automated by using CloudFormation templates and using what we call playbooks, which are a combination of some of these CloudWatch actions using the AWS System Manager automation. An example of such combination of these is available at the URL referenced here, where customers can take a pre-built automated response and remediation solution architecture and deploy a CloudFormation template. This is just one example. Customers can actually create their own custom playbooks as well, and then deploy them using CloudFormation templates at scale. An example of customizable response and remediation actions is also highlighted here in this slide. Security Hub, being the centralized monitoring and management service, allows for the aggregation of all these findings, from where CloudWatch event integration and EventBridge queue integration allows customers to write their own custom rules. Those custom rules can either fire off additional Lambdas and step functions, from where customers can leverage built-in integrations of Security Hub, such as ticketing and alerting tools like Slack chatbots, or PagerDuty and Jira integrations for ticketing for their security service teams, or sending these findings into a SIEM or SOA tools. As I highlighted, the Amazon Security Finding format, which normalizes the findings format for all these findings from both native security services as well as our integrated technology partner services, allows the security teams to easily then add additional insights on those findings as well. Security Hub also creates insights built in the service, which can provide a good summary of certain things, such as actions you would want to take to protect your Amazon S3 buckets, or actions you would want to take to ensure all your EC2 instances are safe and protected. And those insights can then be mapped to these custom actions as well. Here's an example on which we have a published blog post as well that explains how aggregating the GuardDuty findings into Security Hub and then using the Security Hub centralized aggregation, which is then integrated into Amazon EventBridge, can be leveraged to automate a response and remediation action. In this case, a known malicious IP address or domain is automatically added into a database by invoking a step function after the EventBridge integration. And then that custom action of firing off that step function evaluates those IPs against the policies that might be defined in the AWS Network Firewall, hence preventing any additional traffic coming in and out in the ingress or outgress, depending on the policies. Those policies are then updated by Lambda functions and ensuring that the resources are either protected moving forward or any known malicious content can be remediated from, if there is information that might be coming in or hitting the instances or resources in an account. So this is an example of how customers can easily integrate the native services and build them into their existing DevOps processes for a scalable, customized response and remediation. Just to highlight the best practice for multi-account management, again, here's a reference to an architecture which is now published. AWS Threat Detection and Monitoring Services can be configured and administered with AWS organizations. Security Hub, GuardDuty, and Macie can be integrated using that delegated centralized management account, which allows the security teams or the data governance teams to go ahead and have an aggregated view of all the findings in one place, and also makes it easier to enable these services on multiple accounts, and the onboarding and offboarding of those accounts easier at both the organization level as well as at OU or organization units level, so that this doesn't have to be managed at every single account level. So this is a reference architecture framework which is published. Highly recommend to view that for more details, and as a best practice, follow that for multi-account management. So finally, looking at the advantages that AWS offers, and looking at the layered threat detection and response services, AWS's native services provide the value where customers do not have to go ahead and separately generate logs and or telemetry and feed them into external third-party SaaS tools. These AWS native services automatically ingest these from at the account level and provide that value to the customers. Secondly, these services can be centralized and scalable when it comes to multi-account management using the native AWS organization integration that makes the scale of these services easier. And then finally, using the native integration into EventBridge and or the custom or built-in actions for remediation and response, customers can easily automate and bring that threat detection and monitoring layered security into their current DevOps processes, which reduces the burden on their security teams as well as their security incident and response teams. Hopefully this was helpful to provide you an overview of how customers can leverage some of our core native services for threat detection and monitoring and integrate those into your existing DevOps processes. For more to learn on these services as well as additional services, you can leverage aws.training/security, which is where you can learn as well as train and certify yourself against some of these services. We have a ton of content available, the reference for which is highlighted on this slide. And finally, before you leave today, I want to thank you all, and it'll be great if you can take a quick survey to provide us feedback on this session and the information shared here. With that, thanks a lot and have a great day.